Hello and welcome to another episode of Math in Real Life, creating a love for mathematics, one equation at a time. Before we begin today's lesson on, on the COVID-19, I want to make sure that while I express that this is a serious pandemic, right? And while I get excited about numbers because I can see the mathematics behind it, what's really happening is that each number represents a life, a family that's affected. So we want to make sure we share this and we share this with caution. And I realize this for myself that I share this with caution, especially when we're sharing this with our younger viewers. So share it with caution. And I hope you guys learn something from it. This is a real way you can see math in action. So I wanted to share this with you because you can get to see math in action. If you saw my previous video, you saw that I started off with the math problem of the week, and it is surrounding COVID-19, the coronavirus disease. Okay, so on Monday, when I did this problem, we created an exponential function. Okay, so this is the data that we had, right? And the question was, the math problem of the week was to create an exponential function to model the growth of the coronavirus. Okay, where did I get my data from? Well, let's talk about that. I went to the World O-meter, right? And they get their information from United Nations Population Division as well as the World Health Organization. And they have some other sources there. So just so you know where we're getting this information from. This is talking global cases, but I'm actually going to narrow it down and just focus in on United States since that is where I'm located. So I'm kind of scrolling down here. I guess I need to click on United States. So I'm going to scroll down here to get to United States or scroll up. Is it listed in alphabetical order? No, it's not listed in alphabetical order. There it is at the top. All right, so I click on there so I could get to United States, the US. So these are the total number of cases concurrent, like right now in real time. So what I did was I scrolled down to the chart and I noticed that this is an exponential function. Okay, and this is where I'm getting those numbers from. Okay, so just so you know, where am I getting these numbers from? If I kind of pull that to the side, probably won't be able to do that. When I pull that to the side, you see on March 13th, there were 2,247 cases. Let me pull that over here. You can see that that's March 13th. And then March 14th, you see those numbers, how they match up. March 15th, March 16th, March 17th. Okay, so that's where I'm pulling these numbers from. I'm actually pulling it from that website. I noticed that this was an exponential function. Okay, so exponential functions all follow a pattern. All right, so this is a general form of an exponential function. Y equals a to the RT. Okay, what we did in order to get these different components, okay, so what I did in order to get the A, to find A, or I should say A is the initial value. So A equals the initial value, okay? So that's day zero. Whatever your day zero is, that's A. R, and a shortcut to finding R, it is the ratio of day 1 divided by day 2. Day zero, sorry. It's the ratio of day 1 divided by day 0. Okay, so that's just an easy way of saying how do you find A, how do you find R? Okay, because A and R represent real numbers, right? And so I would say where A and R represent real numbers. Okay, so that is kind of how you break down creating this exponential function, okay? So A is the initial value. That's what happens when it's day 0. R, in layman's terms, is the ratio of day 1 divided by day 0, okay? That's where I'm getting this information from. Okay, so that is the science behind the general form of an exponential function. Okay, so that's where we're getting that information from. That's how I'm creating that model. Okay, so here is a continuation of our math problem of the week. Is Monday's formula y equals 2,247 times 1.3 to the x power still valid? Now, if you want to see how we got that formula, you can watch the other video. I'll link it in the comments below. Okay, so is it still valid? Well, let's go ahead and plug in some values and see how that works. So what I'm going to do now is I'm going to go to my trusty calculator. I like using WebCal. It's a scientific calculator. I'll link that in the comments below. So what I'm going to do here is I'm going to put in the initial value, 2,247, parentheses, 1.3, close parentheses. This is how I get my exponent, okay? I'm trying to see if it's still valid. So let's see what, this is how the actual cases, let's see what the predicted cases would be. So I would do to the third power to figure out how many we predicted would be on March 16th. And based on those numbers, we predicted there would be 4,937 cases, because we can't have a 0.6 of a person. That's how many we thought there would be on March 16th. Did I put everything in there right? 2,247, 1.3 to the third power. Okay. And then let's go ahead and look at this again and see how many we predicted would be on March 17th. So that would be day 4 in this case. So I'll change that to 4. And the prediction would be there would be 6,418 cases, because you can't have a 0.6 of a person. That's how many we predicted would be on day 4. And then again, go back to that same formula. Let's see how many we predicted would be on day 5 based on that formula. And it's the prediction that there would be 8,343 cases on March 18th. And let's just go ahead and let me just go ahead and put today's date, which is March 19th, in there. So that would make it day 6. So we predict there would be 10,846 cases on day 6. And that would be March, go ahead and type that in there. That would be March 19th, day 6. That's how many cases we predict would be on day 6. Okay, so these are the prediction model based on this formula, based on Monday's formula. All right, so let's look at March 16th. Look at the numbers. So there were less cases, praise God, on March 16th than predicted. So that's great. There was about, we can go ahead and subtract, right? We had 4,937 cases predicted. And there's actually 4,663 cases that actually came about. So we were less, we were 274 cases less. So that's great. But then on March 17th, we predicted there would be 6,411. There were predicted 6,418, and actually there was 6,411. That's only a difference of 7, which isn't good. That means it's still following an exponential curve. So here the difference was 7. Here the difference was 247. Let's go ahead and take a look at what it actually was yesterday. So yesterday we predicted there would be 8,343. Hopefully it's a lot less than that. So let's take a look at March 18th. There are 9,259 cases yesterday. $9,249 cases yesterday. 59. Wow, guys. So, unfortunately, this is still following an exponential curve. So that's 916 more than we thought should be happening yesterday. And that should really be red, not green, right? These were minuses. I'll make those green because we were less. We want to be less. We want to be less than an exponential curve. So what does that mean? I think that means we have to be more diligent with what we're doing, right? You know, this is not a linear function, this is an exponential function. So those who know anything about mathematics, exponential functions, that means it goes up pretty quick and it continues to grow. Okay? You want your money to do that, but you don't want this virus to do that. Okay? So we really need to start paying attention to what the CDC and what our government is saying about the social distancing. All right, so for today, March 19th, let's look at how many cases we have currently right now. We're still following the curve. So to answer the question, is Monday's formula still valid? I would say so. I would say it's still valid. It seems the cases are still kind of mirroring the formula. I wouldn't quite revise the formula yet. I wouldn't want to increase this ratio. Okay. But I'm going to come back next week and take a look at the formula again, and hopefully we'll be able to revise this ratio, and this ratio will be smaller and not bigger. So what can we do in the meantime? What can we do in the meantime? Let me clear all these drawings right here. And let's jump. So what can we do in the meantime? We already answered the question. Not only do we want to do the research, but we want to go ahead and check out the CDC, see what the recommendations are, right? If you want to pay attention to the numbers, if you want to find the numbers out for yourself, you can go to this website, Worldometers, and check it out there. If you click on a CDC website, it tells you, it gives information on how to protect yourself, what to do if you think you're sick, and other things you need to know, and how to prepare your family. So check that out, you know, stay on top of it. And hopefully when I come back next time, it will be with better news that we're no longer on that ratio for the exponential curve. Our exponential curve has slowed down significantly, okay? So the goal is to flatten the curve, as they say, right? Flatten the curve, flatten this model. We don't want it to be exponential. Thanks for listening, and I'll see you guys next week.